All right. So yesterday we spent the day talking about bonds-off coalitions. Some things that we know about this. Okay, order doesn't matter. Okay, order doesn't matter. So that means if I pair the numbers 8 and 6 together, I can write 8 then 6 or 6 then 8. It still gives me a total of 14.
Right.
Okay, so order doesn't matter. I told you guys to go from greatest to least because it makes it easier, but you don't have to. Okay, another thing about bonds-off, your number of players can change. So your coalition could be one person by themselves, 2 people, 3 people, 4 people, 7 people. Okay. Today we're going to talk about the Shapley Shubik coalition. Okay. One thing you need to know about these is order matters. Okay. Order is going to matter here. The second thing you need to know about these is all players are in every coalition. Okay. So if you have 5 players, you need to have all 5 in every coalition that you create.
Wouldn't that make all coalitions the same?
No. Technically, yes, in total, but what we're doing with these ones is different. Okay. So, Shapley Shubik, we use what we call sequential coalitions, which is an ordered list of all players voting. Again, player 1 before player 2 is different. Oh, yeah, different. Different than player 2 before player 1. So the way I tell everybody to do this and what makes it easiest is start with one number and do all of your sequential coalitions with one number. So here we've got 3 players. They have weights of 8, 6, and 4. So a sequential coalition would look like this. 8, 6, 4. It contains every player. What's another way that I can write this starting with the number 8?
4, 6.
4, 6. Is there any other way to write this with the number 8 in front? No. Now move on to your next number. 6 can go in front. I can do 6,
4, 8.
4, 8,
4, 6, 8, 4.
and 6, 8, 4.
Okay, you got it. I need you to explain that a little bit. Just say order matters.
For the bonds-off coalitions, the order doesn't matter.
So this is what we're doing right now. Bonds off.
No, we are doing sequential
Wait,
coalitions.
what? You just confused me too.
How? Bonds off is what we did yesterday.
Okay, but that, you said for that one, order doesn't matter.
Right.
And you just said for this one, order doesn't matter. So I automatically thought. No.
Where did I say for this one order doesn't matter? I'm pretty sure at the top.
No,
We
right
wrote
there
order
in the
matters.
red. In the red.
And then you put them out of order.
Yeah.
No, like 8, 8, and 6, 6. Then she don't do 4. Like she don't do the 8s first, then 6, and then 4.
What? She's saying that.
I'm
order
saying
is
that this
different.
is different than this.
Yeah. Because
Even
they're
though they
different
have the
because
same
order is different.
total, they're.
Okay, I'm
How
trying.
do I explain that?
Okay, so she said order matters. So first she don't start off with the 8, then she starts with the 6. Then next she don't start with the 4.
You need to come up with all of your different coalitions.
Oh.
Okay.
Okay.
Order matters. So that's saying what's the total of 8, 6, and 4?
18.
What's the total of this?
18. 18.
These are all 18s. These are all different ways to order them and still get your same total. I don't know how else to explain it. We're gonna pray on it. But it's still, it's not gonna, I understand where he's coming from, and I don't know how to phrase it to make it. Let me think on that. I'll come up with something by the end of class.
Pretty much you just put it in different sets. The only thing that's changing is like the other slide.
No, it's changing.
I know like the total is the same, but like the order is like on the slide.
Okay.
So when
So-
you listen to them, the order does not matter. Is what you're saying.
It's just the number in front.
all the orders.
It's just the number in front.
You have to list all of the orders. That's why it matters.
And Bonhoff, if I put 8 and 6 or 6 and 8,
It's
it was the same thing.
Isn't it the same for the other one too?
No, these are different.
Why do we need to put the different orders though? What is that?
Because of what we're gonna do with Shapley.
Oh.
Because we're gonna look at pivotal players.
I honestly don't even understand much of why we need coalitions or anything like the first thing we did, I could understand how it would apply in real life, okay? But like, I just don't understand, because I assume it still has to do with voting, because it's a voting system, right?
Yes.
But how does that, how does one player have 8 and one player has like 6, for example, in a voting situation?
Okay, so look at your, no, not Donald Trump. Look at the Electoral College. California has more votes than Vermont.
True.
Okay, so this is kind of like that,
Okay.
where one state has more power over the other because of population. Except instead of population-wise, this is more like a school system. So Miss Curry would have 8 votes compared to the teachers who may have 6 votes compared to y'all who may have 4, because she has more power.
Okay, that makes sense.
Okay.
What would you need to rearrange the order of them for though? Or, for example, like what we did yesterday, what would you need to find all the different possibilities of order? You know what I'm saying?
Wow, was good.
Okay. If you paired, let's say in the school system, in order to pass anything in the school system, you need a vote of 10.
Okay.
Miss Curry has 8, I have 6, and you have 4. Okay. Miss Curry can't win all on her own. Obviously, she's got the superintendent or what that has most of the power. Okay. But if Miss Curry and I pair together and say yes for something and you say no, it'll still pass. We could pair up Miss Curry and you could agree and I could not. And you all could still pass something over top of me. So it's just different ways that you can pass things depending on how much power you have.
Okay.
In this, let me get to the next piece after we're done with sequential coalitions, and hopefully maybe this will click a little bit more. Okay, this is kind of like Miss Curry votes first, I vote second, you vote third. In this one, Miss Curry votes, you vote, I vote. Okay, so they're different. The order matters in the order of how we vote. Okay, I can line up 3 different people 6 different ways. Okay, give me 3 people.
Me? Oh no, bro, let's sit down for us.
Okay. I've got 6 different ways to order these 3 people. Face up. Okay. I can put Natroya, Trey, and Alexis. Or I can switch these 2. And Natroya can go first, then Alexis, then Trey.
She looking strong.
Okay. Or I can switch these 2 around. Okay. There's 6 different ways to order these people.
She got fed.
And it's different every time. Okay. That's what we're searching for. All the different ways to order these 3 people in a sequential coalition. Does that make a little bit more sense, Trey? Okay. So I'm trying to figure out all the different ways I can put these people in first, second, and third order. Okay. So 8 is in first in these 2, second, third, first, second, third, first, second, third, first, second, third. The only person we haven't put in first yet is
4.
4. So we can do 4, 8, and 6,
4, 6, 8.
or 4, 6, and 8. All right, the next one. We've got 10, 5, and 5. So don't forget, make this 5A and 5B. Okay, player 2 has a weight of 5 and player 3 has a weight of 5, but they're 2 different people. So I can start this out as 10, 5A, 5B. How else can I order starting at 10?
10, 5B, 5A.
5B, 5A. Okay,
5A,
we can start with 5A.
5B,
Oops, 5B and 10, or 5A, 10, 5B. And my last person that needs to come first would be
5B.
5B. You can do 5A and 10, or 5B, 10, and 5A. So when I say order matters, Trey, that means it matters who I put in first place, second place, or third place.
Okay.
Okay?
Okay, so can
So each one of these had 6 sequential coalitions. Okay? We find that by using a factorial button. But first, let's back up and talk about how to find the different ways to match up outfits. So remember back to, I know I teach it in Math 2, okay? So those of you that had me in Math 2, when we talked about how many different ways can you wear an outfit if you have 5 shirts and 6 pairs of pants? Do you remember what we did?
Girl.
What was it?
5 times 6.
5 times 6. You've got 30 different outfits you can make. You've got 5 pairs of shirts that you can match with 6 different pairs of pants. So that's your multiplication rule. It says if there are M ways to do things, if there are 5 shirts, and there are N ways to do Y, 6 pairs of pants, then we take M times N, and that's the total amount we can do. So if you have 5 pairs of shirts and 6 pairs of pants, you have 30 different ways you can wear that outfit. If we've got 2 shirts, 3 pairs of pants, and 2 pairs of shoes, it's 2 times 3 times 2. Okay? Sequential coalitions, though, we're looking at something called factorial. Okay? Factorial means the product of the first n positive integers. Okay, I will show you where this button is on your calculator, but you need to understand the meaning behind it. So, if I have 3 factorial, that means I start at the number 3, wherever that's at, and I multiply by everything below it. So 3 times 2 times 1. 6. If I have 5 factorial, that means I start at 5 times 4 times 3 times 2 times 1.
120.
There's 120. Watch what happens here. I have 5 factorial over 3. So 5 factorial says 5, 4, 3, 2, 1. 3 factorial says 3, 2, 1.
Can we just put 120?
Yeah.
All you're left with 5 times 4, which is what?
20.
a word.
Right. You can also do like 120 divided by 6, right? You still get the same as
Only if you have those first, though. And on your test, you're not going to. I'm not making it that easy.
Oh, you gotta be complicated for it.
Number of sequential coalitions then. To find out how many of these I need to create, I use the formula n factorial. So if I have 3 players, I have 6 ways to write out coalition. If I have 4 players, we have 24 ways to write out coalitions.
That exclamation point.
Yes, that is your factorial button in that. That means factorial. All right. On your test, you're going to see a section that looks like this. There won't nearly be as many examples. Okay. But in order to do this, you're going to have to write out what you would plug into your calculator. So if I give you 7 factorial on the test, I want to see 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. I'm not looking for an answer. I'm looking for, can you write it out? So then 8 factorial. All I do is start with 8. 7. Okay. If you want to find the actual answer for that though, type in 8 on your calculator. Hit math. Scroll over to probability. And it's number 4 is your factorial button. Choose that and then hit enter. 40,320 is your answer.
So you want us to.
Okay. I'm looking for this.
What about
On your
for
test.
200 over 199?
Okay. Hold on. I am getting there. Let me get through the examples that come before that. Okay. Take a look. 8 factorial over 7 factorial. That means I've got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Where does the bottom start at?
7.
7. Okay. So the easiest way to do this, what don't these share in common? What number do they not share in common?
8.
That's it.
Number 8 is 20.
Okay. So what you want to do is you're going to start at this number and keep going down until you hit this number and stop. So jump down to, let's go up to 7. Where do I start at the top? 12. Times 11. What's my next number? 10. So I stop. 132. Okay. You can stop right when you get to the number of the bottom. Okay. So then number 8, Marcus.
Yes.
200, 199. What's my answer?
200.
200. Number 9. I would multiply 23. That's it.
3,507.
Okay, this is 6 times 5 times 4 times 3 times 2 times 1. This is 4, 3, 2, 1. Be careful with number 6. What's different of number 6 than number 7?
Doesn't have a.
There's no factorial there. So you literally need to do 6, 5, 4, 3, 2, 1
Over 4.
divided by 4. The only thing you can cancel out is your 4s. So your answer then would be 6 times 5 times 3 times 2 times 1. The only one you can skip is the 4. Okay, number 10. 10 factorial is this.
Oh.
How would I go backwards and get 9 factorial just using that answer?
Divide that by 10.
Why?
Because last thing it was multiplied by was 10.
Good. This one's not multiplied by 10, right? This starts 9, 8, 7, 6, 5, 4, 3, 2. The only difference is this one's multiplied by 10. So to get this answer, we would start here and divide this by 10. We're working backwards now. So 3, 6, 2, 8, 8. 0. Then for part B, if I started out with your answer for 10 factorial, how would we get 11 factorial?
Multiply by 11.
Multiply by 11. Questions? All right, let's get into the nitty-gritty. Okay, why we're doing this, why we're writing sequential coalitions. We are trying to find your pivotal player. Okay, so your definition of a pivotal player is the player in a sequential coalition whose votes make the coalition winning based on the order of votes. So as the votes are coming in, we're adding them up. When I get to my quota or more, I stop. That player's pivotal. Okay, so there's only one pivotal player. Okay, so unlike Bontoff, where you could circle several critical players, we only have one player that is pivotal. Okay, so what we do is we go to each sequential coalition and we start adding from the left. So we're at 3. 3 plus 4 is?
7.
Plus 8 is? 15. I've hit my quota. 8 is pivotal.
Oh,
It's that simple.
It's that simple.
So what's the one?
That's why the order is different.
Let us try the two.
Okay, let's do this one all together. Calm yourself. We got lots of time. Okay, we start at 2. 2 and 8 is 14, 17. We finally hit 15. We start at 2. 2 plus 3 is? Plus 4 is? Plus 8 is? Okay, so 8 is pivotal.
Okay.
Okay, you want to try number 2 and we'll look at it? Try number 2 and we'll look at it. The more practice you get on your own, the better off you are. I can sit here and talk all day long and tell you all the answers, and it's going to do you no good.
Done.
And the third one too.
So,
If you're good with 2, go ahead and do number 3.
Someone wants to show up.
That's actually
Okay,
Can I circle it?
this time my quota is 27. Who is my pivotal player in A?
3.
3. Okay, watch what happens. 10 plus 12 is 22, plus 4 is 26. We don't hit 27 until we get to 3. Okay, what about this one? 4. And the last one is 12. Okay, what about number 3? 20. This person wins off the bat.
It's always
Okay.
It's
Always 20?
Yep.
16, that's 20. Questions? Okay, now we've got to put all of this together. Okay, so what I mean by that is we have to come up with your sequential coalitions, and then we've got to find your pivotal players. So, example number 1. Okay, I have 3 players. So that means I have 3 factorial coalitions, which is 3 times 2 times 1, which means I should have 6 different ways to order these. Okay, this tells you how many you should have laid out.
Wait, we get
3 players.
Oh, okay.
There are 3 people, 6, 3, and 2.
That's why it's 3-1.
Okay,
That's
3 players. No, that is not a 1. It is an exclamation point. Okay, so I have 6 different ways to write this. Okay, so let's start with what they give us. 6, 3, 2. How else can I write this?
6, 2, 3.
6, 2, 3. Okay,
3, 6, 2.
3, 6, 2.
3, 2, 6.
3, 2, 6.
2, 6, 3.
2, 6, 3.
2, 3, 6.
2, 3, 6. Not too bad, right? Terrible. Okay. Another way and another trick I found. Okay. You have 6 total ways to do this, right? And I've got 3 players doing it, which means I should have 2 that start with each player. So I've got 2 that start with 6, 2 that start with 3, 2 that start with 2. 3 players.
I didn't hear you say that.
Okay, I've got 3 players, which means I should have 2 that start with each one.
And we're finding
Okay.
pivotal for each one.
Let's find who's pivotal. I need to reach the number 8. So who's pivotal out of 6, 3, 2?
3.
3. 6, 2, 3.
2.
2.
6.
Okay, 6
And then 6 again.
and 6 again.
6.
6
Yep.
And then 6 again.
and 6 again.
Oh, man.
Okay. Now, example number 2. You're going to see one on your test. It is the last one, and it's like 12 points. So please focus. There is a rhyme or reason, and if you pay attention, it's really easy to come up with your coalition. So I have 4 players, which means that's 4 factorial. So 4 times 3 times 2 times 1. I've got 24 of these suckers I got to write out. Okay, it's not that bad. Okay, how many players did I say I had?
4.
4. So, just like I did up top where I divided Jeremiah was given chapter 2 paper the other day. If he lost it, that's not my problem. I don't have any extra copies for him.
Slam the door.
Okay, so if I have 4 players and I divide this by 4, that means I have 6 coalitions that start with each player. Okay, so what that means is I have 6 of these that start with the number 7. Okay, I have 6 that start with the number 7. I have 6 that start with the number 4. Yes, this is a lot of work. I'm sorry. I have 6 that start with the number 3. And I have 6 that start with the number 1. No, there is not. Welcome to Discrete Honors. If you didn't want to do the work, you should have taken a standard class.
They gave you this question.
I did.
They give you 9 plus 6 equals.
Okay, so we need to write out all of these coalitions. So let's start with 7, 4. How else can I order? 7, 4. Where are you getting 2 from? 3, 1. I can do 7, 4, 1, 3. That's it for my 7 4s. Now let's move on to 7, 3. 7, 3, 1, 4. That's it for my 7 3s. 7, 1, 4, 3, and 7, 1, 3, 4. Okay, So you have 6 that start with 7, 2 of each, and then order the rest. So with my 4s, pick a number to go after 4.
7.
7. 4, 7.
3, 1.
1, 3.
3, 1. 4, 7. 1, 3. Okay, that's all my 4 7s. Give me another number.
3.
3. 4, 3.
7, 1.
7, 1. 4, 3. 1, 7. My last one,
1.
4, 1.
3, 7.
3, 7.
3.
And 7, 3. Okay, we move on to my 3s. What can come after 3?
7.
7.
1, 4.
1, 4. 7.
1.
4, 1. 4s.
7. 1.
7, 1.
1, 7.
1, 7. And 3.
1.
1.
7, 4.
7, 4. 1, 4, 7. Do you see the pattern that's happening here?
Yeah.
You are going to see one this big on your test. And I suggest you don't skip it unless you don't ever want an A. Okay, finally the last one, we're starting with 1.
1, 7.
1, 7. So we're gonna do
3, 4.
3, 4,
4, 3.
and 4, 3.
1, 4, 3, 7.
1, 4, 3, 7, 1, 4, 7, 3, and finally 1, 3, 7, 4, 1, 3, 4, 7. We're not going to circle our pivotal players right now. Okay. Breathe. We've got what? One more page of notes to finish? I think this is a lot easier to write out than the winning coalitions.
No, it is. Yeah.
Because you actually have to think about the winning coalitions and how many there are. Okay. All right. So everything's the same as Bonhoff, except we're doing sequential coalitions. So you need to come up with all your sequential coalitions. Find your pivotal player. And then we're going to count just like we did with Bonhoff. How many times was a player pivotal? How many times total did we have? And find your fractions. So sequential coalitions. I've got 3, 2, and 1. So 3, 2, 1. What's my other ones?
3, 1, 2.
3, 1, 2.
2, 3, 1.
2, 3, 1.
2, 1, 3.
2, 1, 3.
1, 2, 3.
1, 2, 3.
1.
And 1, 3, 2. Okay, let's find our pivotal players. My goal is to reach 5. So 3, 2, 1, who's pivotal? 2. 3 plus 2 is 5. 3, 1, 2.
2.
2, 3, 1.
3.
2, 1, 3. 1, 2, 3. 1, 3, 2. Okay. All right. So now, just like Bonhoff, how many times did we circle player 1, which had a score of 3? 3 times. How many times did I circle player 2, which was a 2? 3. How many times did I circle player 3, which was a 1?
1.
1. What's my total?
6.
6. So player 1 is a 3 out of 6 or 1/3. Or yep, 1/2, not 1/3. I'm looking at the 3 like 1/2. Player 2 was a 3 out of 6 as well, which is 1/2. And player 3 is just a 0. You've got to write out the coalitions, find your pivotal player, count up how many times, divide by the total. Questions? Okay, let's try this one.
Can't feel my wrist.
Oh, am I making you do too much work today?
Yes.
Do I need to move on like I did in the last class?
Go ahead.
No. No.
Okay, I'll start you off. 9, 8, 7. 9, 7, 8.
8, 7, 9.
8, 7, 9.
8,
8, 9, 7.
7,
7, 9, 8. 7, 8, 9. There is one with 3 players and there's one with 4 players on your test. Okay, my goal is to reach 16. Who is pivotal out of 9, 8, 7? 8. What about the next one? 7. 9. 8, 9, 7. 9. 9. And 9. So, player 1. How many times was player 1 pivotal? 4 times. Player 2.
1 time.
Once. And player 3. Once. For a total of 6. So these are all out of 6. So 4 6s.
2/3.
2/3.
Yeah.
This is just 1/6 and 1/6. What do you have? One more example?
Yep.
Is that another 4 person?
Nope, it's one that repeats like 5, 8.
Yes. Why? Because I'm making you do work?
No, because I don't like that.
I look at you.
Okay, so all we do is we make this 5A, 5B. Okay. So 15 5A, 5B, 15 5B, 5A.
5A.
Okay. Now we want to do all your 5A's. So 5A, 15, 5B, 5A, 5B, and 15. And then we've got our 5B's. So 5B, 15, 5A, and 5B, 5A, and 15. Don't mind my really, really bad B down there. Okay. Just remember, if I've got 3 players, that means I've got 3 factorial coalitions, which means I should have 6. 1, 2, 3, 4, 5, 6. I don't give you those formulas just to give them to you. They're to help you. Okay? Who's pivotal in the first one? 15, 5, 5. 5A. 5B. 15. 15. 15. 15. Okay. So, player 1 was your 15. How many times was it critical? 4. Player 2 was 5A. Player 3 was 5B. 1 out of 6. So again, 2/3, 1/6, and 1/6. Questions? Your homework tonight are those 3 problems at the bottom of your notes. 24, 25, and 27.
Monday.
No word.